Let's see. Okay. So aluminum reacts with oxygen to produce aluminum oxide. Okay. Okay. Calculate the mass of aluminum oxide that can be produced if you have 52.9 grams of aluminum and sufficient oxygen and 70% yield. Okay, all right. So I'm just gonna write the chemical reaction. So how far have you gotten on this problem?
Well, this problem, I was trying to work on it. So I remember when we were having our lecture, he said something about like doubling it, like to multiply it. But then when I'm trying to do it, I don't know where to start.
Okay.
Yeah. So I haven't really started the problem.
All right, just writing it down. So we're going to start with our 52.9 grams of aluminum.
Okay.
So we start with this. And our goal is to use stoichiometry to go from aluminum to aluminum oxide.
Mm-hmm.
Now, because they tell us oxygen is in excess, that basically means we have as much oxygen as we need, so we can just we don't have to worry about the limiting reactant.
Okay.
So whenever you go from one element to another element, you're gonna have to use, it's gonna have to be from moles to moles, moles of this thing to moles of another thing. So
Oh.
you start with grams, which means you are gonna have to turn this into moles at first. So we're gonna use the molar mass of aluminum. So 1 mole, oops, 1 mole of aluminum is gonna be equal to, let me see, what's the molar mass of aluminum? Mole.
The mole of aluminum?
Yeah.
Is it 26.982?
Yep. Yeah. That's it. So 26. I'll just leave it at 4 sig figs.
Okay.
26.98 grams.
So whenever it says 1 mole of aluminum, you always have to see what the mole of aluminum is to finish processing and solving.
Yeah, because if you see, we cancel out the grams, and now we have moles of aluminum as our units.
Okay.
So we effectively found out how many moles of aluminum this 52.9 grams is. So now we can switch from aluminum into aluminum oxide, and we're going to do it by this. So for every 4 moles of aluminum, you're going to produce 2 moles aluminum oxide. And you get this, you get the 2 and the 4 from your reaction and the coefficients over there. Because the reaction tells you how much you need and how much you'll make.
Mm-hmm.
So this is like your true goal. This is the thing you need to do to go from one element into another. But you can only do this with moles because these coefficients are moles. So
Oh,
that's why we
okay.
use the molar mass to go from grams to moles.
Okay, that makes sense.
Okay. So after this, we're left with moles of aluminum cancels out, and we're left with moles of aluminum oxide. But they want us to get the mass of aluminum oxide, so we're going to have to use the molar mass again to turn these moles into grams.
Okay.
So 1 mole of aluminum oxide is going to be 26.98 times 2 plus 16 times 3. Let's see, what is that? So it should be 101.96 grams. Of aluminum oxide. So now that we've turned it into grams, we've basically solved the problem, but this has the extra thing of saying it has 70% yield.
Yeah.
Which means like this would calculate the theoretical amount you would create. So we have to, basically it's like 70% yield means if you could theoretically make 100 grams of it, you would actually only make 70 grams of it. You somehow just lose 30%, because you dropped it or it's just inefficient somewhere.
Okay.
So the way I usually do this is like this. So for every 100 grams of theoretical, we only get 70 grams actual. And I'm putting theoretical on the bottom because, well, this is calculating mathematically the maximum amount we could create. So this would be the theoretical grams that we could create, which is why I'm putting it over here, so these grams would cancel out.
Oh, okay, I see. You have to
So this would be just doing the math. Times 2 divided by 4 times 101.96. And then times 70 divided by 100. Okay. So I got 69.97. I'm just going to round it to here, grams of aluminum oxide. And then you have to do sig figs, so that would be 69 point, well, I guess it'd actually be, working with 3 sig figs, it'd be 70.0 grams. Another way you could do it, if it makes sense, is you could, instead of writing that part,
yeah,
you could get to here. So this would give you, this would calculate the theoretical maximum you could create. Divided by 4 times 101.96. All right. So you could theoretically create 99.96 grams. But you only have 70% efficiency. So you lose 30% of this. So you would just multiply this by 0.7, and you will get the same answer.
Oh, okay, because I remember him,
Mm-hmm.
like our professor, he had a lecture actually on this. So when we were doing it, I heard him say like you have to double it, and I guess he just multiplied it like that instead of doing what you did before. He just multiplied the 99 times 0.7, which got the same answer.
Yeah, I guess so.
Yeah, so I was like, I didn't understand how he did it. So your way kind of made more sense.
Okay. Yeah, because it just depends on what you want to do. Maybe this makes more sense. I'm just writing the percentage as a decimal. So we're only getting 70% of what we could possibly make. And this is your true goal. to turn from this element into this element. But you have to do moles to do that, so this turned your starting grams into moles.
Mm-hmm.
And then after you do this step to get your moles of aluminum oxide, you have to turn those into grams. That's your theoretical maximum, and then you have to multiply by your efficiency or your yield. But that's it, yeah.
So the answer would be 70.0.